Welcome. The workshop has begun, and this is now when we wait for people to trickle in. I think always this kind of situation is much easier to handle in a live room where people would start walking in and sitting down and making themselves comfortable. But I have no visual reference to how many people are joining us right now. So if you are joining us right now, please say hi in the chat. Oh, look, we've got 45, 46 people, 47. Everyone is joining. Welcome in. Terry, you are the first person to say hi. I appreciate you all very much. Coming in strong and fast now. And we'll get started at 2 minutes past the hour. So you have 2 minutes to come on in. Wow, you're in Seattle, Rob, and you're coming from Seattle live. That is early. It is currently 2 a.m. in Seattle.
Oh, very keen. It's good.
Hello, everyone. Come on in. I mean, the first slide I have to say is introduce yourself and say where you're located. And you're already doing that as if by magic. From New Zealand as well. Me and David were just talking about how it's what it's like to work with people in New Zealand, in the United Kingdom.
Yep.
There's people from Nairobi coming in, Cancun, Munich. We are a truly global workshop today, David.
Yeah, it's exciting. And to be clear, we were saying how great it was to work with people in New Zealand. It's just the time zones were funny.
Yes. Stockholm, Prague, great stuff. This is so great to see. We've got 59 people so far with less than a minute to go before we start officially. We're going to have some awkward next slides, please, because David is sharing his screen and I am not sharing my screen, but I will be doing the first few slides to introduce you to the workshop today. And it is 2 minutes past. So David, next slide, please. All right, so welcome to the workshop titled Taming the Kraken, Managing a Python Monolith with Sentry. I won't be talking very much today, thankfully. It's all going to be mainly handed over to David Winterbottom from Octopus Energy, who will be telling us all about how they use Sentry to manage absolutely wild amounts of releases every day with the amount of developers they have. Next slide, please, David. So you've already been doing this, so thank you very much. We've got people from all around the world. It's quite astounding, actually, that people are coming in from everywhere. Sentry, we've recently started to target the EMEA time zone, Europe, Middle East, and Asia. And actually, everyone is here from everywhere. So welcome, Edinburgh, Berlin, Bordeaux. Cheers to you, Pascal. Welcome in. So it's great to have you all here. And I hope you're going to get some really useful insights from David today. Next slide, please. Okay, quick housekeeping with a little sweeping brush. We're going to have some Q&A after the presentation at the end. If you have a question for David, please add your question to the Q&A tab at the bottom of the Zoom window, not in the chat. Probably going to miss chat messages. So please, if you have an important question, use the Q&A. You will get a recording sent to you within the next 24 hours if you want to recap, if you want to go over some other things that David said that you kind of missed. So don't worry, you will get to relive this amazing experience 24 hours later, and a survey window will pop up at the end of the workshop. Please fill it out. It won't take long. We really want to help. We really want you to help us understand what's good about these workshops, what could be better, what you enjoyed, and how we can give you even better workshops and content in the future. So I'd appreciate you doing that. Next slide, please, David. Okay, so here's what's going to happen today. When I have stopped talking, David will tell you all about how Kraken uses Sentry with some error monitoring case studies and all that good stuff. And I'm first of all going to tell you a little bit about what Sentry is if you are new to Sentry. And then for the rest of the workshop, after David's wrapped up, we'll do the Q&A. Again, please use the Q&A in the Zoom window thing. Next slide, please. All right, so this is the Sentry platform. It gives you, as developers, everything you need, pre-production and post-production, to understand what's working with your apps and what's not working with your apps. And the only thing Sentry can't do is fix the things that are wrong. So we've got Code Cov, which is test coverage for your pre-release pipelines and CI/CD. And after the feature is in the wild, you can monitor your applications, get alerts about any errors that happen, and trace those errors right through to the line of code that error came from. You can use, there's breadcrumbs in Sentry that I really love that tell you everything that happened up until the error happened. So you actually never need to recreate these bugs locally on your local machine when you get a call at 2 a.m. That tells you a customer can't check out. Everything in Sentry puts the context, gives you the context all around what's happening and allows you to resolve things really, really quickly. The only thing you need to do is write better code to fix it. And what we're really, really working on, especially now, is also our performance product. So you've got your errors, but you don't need Sentry for errors all the time if your code is absolutely perfect. But you do need Sentry for performance, to monitor the ongoing performance of your apps, to make sure your core web vitals are up to scratch. So you get that sweet SEO juice from Google. And one of the great things also is you've got session replay that's connected to both performance and error monitoring. You can see exactly what your users did, again, without needing to recreate those bugs and errors that happen. So we give you everything. And one of the things I really love about Sentry as well, it's like completely cross-platform, mobile, desktop apps, back end, front end. You can connect all of your little microservices together. And I'm sure we'll hear a little bit from David about that, how that works as well. It's really everything you need as a developer, apart from writing the code. Next slide, please, David. Okay, so here is, I think I'm going to hand it over to David now. This is about managing a Python monolith with Sentry. David, please tell us about yourself and then kick off the presentation. I'm going to hide my camera, monitor the Q&A and the chat, and I'll see you after the presentation.
Thank you, Salma. Right then, so got a little section on introductions where I'll explain a little bit about who I am. A company that I work for, Kraken Technologies, which is part of Octopus Energy, like it says under my name, and a little bit about this Kraken platform that we maintain. This is the big kind of Python monolith, which is one of the applications we use Sentry with. So, who am I? Well, I'm David Winterbottom. I am a principal engineer at Kraken Technologies. So Kraken Technologies is part of Octopus Energy. I'm a very early employee. I've been there since the start and kind of seen us grow from kind of 10 people to I think more than 5,000 people now. I'm mainly a Python engineer. You know, I've been writing kind of Python for, I guess it's probably coming up to 20 years, something like that. But my role at Kraken, at Octopus, is more of like a general caretaker. If there's a problem that no one really owns, then it's kind of my problem. And I try and help, you know, steer the 500 or so developers we have in the right direction in terms of making sure team structures are right and our processes are right, whether that's around testing or deployments or documentation. I'm a general caretaker, really. One of those things is actually working with our vendors like Sentry, a key vendor, making sure we're making the most out of the, you know, the services we pay for, and making sure that people in the company, you know, have the training and support to use them effectively as well. Okay, so that's who I am. So Kraken Technology. So as I said, this is like the technology tentacle of the wider Octopus group. So Octopus Energy started 8 years ago as a kind of energy supplier for the UK. It's got a well-known brand now in the UK. I think we're the biggest electricity supplier there now, and we have Octopus companies in France, in Germany, in Spain, in Japan, in the States, soon to be in the Middle East and Netherlands. Anyway, we're growing very rapidly. We've always, well, our kind of aim, if you like, our company mission is to make a big green dent in the universe. So we're trying to drive the adoption of renewable energy, providing a kind of better, faster, cheaper utility platform that enables, well, has enabled Octopus Energy to do that in the UK, but will also enable other companies, other energy suppliers around the world to do the same thing. And well, as I say, we're about 5,000 people now. A lot of people in our random channel on Slack, for instance. And Kraken Tech is about 500 people within that. And as well as trying to make a big green dent in the universe, another key thing about us is put a lot of effort into looking after our customers. If you work here, you see this in evidence where if there's ever a complaint or anything like that, a lot of energy goes into making that right for the customer and making sure we treat our customers really well. And the evidence for that is if you look at, say, the Trustpilot ratings in the UK, we've been #1 for many years now. Recently, we won this kind of Which Recommended Provider Award in the UK, which is quite the most prestigious award, if you like, in energy. And that's the 7th year running. That's fairly unprecedented as well. Anyway, so I'm just trying to say, we're all about renewable energy, fighting climate change, and really looking after customers. Okay, so that is Kraken Tech. At the core of what Kraken Tech provides, or what has driven the success of Octopus Energy, is this platform called Kraken. Now, it started off as just like a really simple Django project, and it's now grown into a kind of utilities platform, if you like. And it does lots of things now. It is like a CRM, it has all the facilities for looking after your customers. It's got a whole financials part for doing billing and invoicing and processing payments, managing ledgers, managing debt, all this kind of thing. There's lots of functionality around comms. We have our kind of own kind of equivalent of Zendesk or Intercom, if you like, built into Kraken for managing all interactions with a customer, whether that's via email, by letter, by WhatsApp, SMS. There's lots of other channels, well, phone calls, of course, as well. And that's integrated into the kind of whole platform. And so it's super easy for people who are using, for staff using Kraken, to get an email from a customer. It will immediately look up information about their energy status, where they're up to, are they moving, are they in debt, how can we help them? And we make things kind of one click, super efficient for our staff to kind of respond and help them solve their problem. Of course, being an energy platform, we have to integrate with lots of different energy industries all around the world. And we've done some cool stuff over the years around machine learning. We use AI now, especially within our kind of comms components, for generating responses and responding to customers in an automated way. And we've got a track record of kind of delivering innovative tariffs, like tariffs that track the wholesale markets, like changing price every hour, every 5 minutes. We have an intelligent Octopus product, which is in the UK and soon to be the US, for electric vehicle owners, where you can plug your electric vehicle in and kind of give us control of your kind of charging schedule. We'll charge your vehicle when electricity is cheapest in the night. It means you pay a really low price for it. Sometimes we even pay you. If there's too much generation going into the grid, you actually get paid to take energy off it. So we've done some cool things with the tariffs. Okay, so that's Kraken from a kind of outside perspective. It's a global, fast-growing product now, so it's used by Octopus Energy in the UK. We license it to other suppliers, so we've evolved from being a kind of single product energy retail company to being like a kind of global energy platform provider or something like that. So it's now deployed to 17 different countries around the world. I think 19 separate suppliers license it from us. We have something like, well, more than 50 million kind of customers contracted to use it. And we've now expanded outside of energy, and we're starting to deploy Krakens into the kind of water and broadband markets. Okay. So I hope I've convinced you that kind of Octopus is kind of been successful, and this kind of Kraken platform has kind of been the heart of that growth. But let's talk about what Kraken's kind of made of. Well, it's largely Python applications within this platform, deployed into AWS, managed with Terraform, that kind of thing. And we use a monorepo approach. We have one very big repo, really, that manages quite a few Python applications. We have some other repos as well. We have some other services, but we certainly have stuck with this kind of monorepo approach for a long time. And that's kind of largely what I'm going to be talking about today. So yeah, so one big repo deploys out to several different services once it kind of goes to production. So it's around 5 million lines of Python. I checked that yesterday, which is quite a lot. Around 200,000 automated tests in our test suite. We're using Django, a lot of Celery, if you know that, which is kind of like an asynchronous broker library that lets you farm work out to some kind of worker pool. If you want to send 1 million emails for meter reading reminders, that's a nice kind of tool you can use for that. We use a lot of GraphQL with the Graphene library. We have a lot of REST APIs using Django REST framework. And what else am I saying? Okay, so one interesting thing is There's been about 360,000 commits in this repo over 8 years, and we've recently went over 100,000 merged pull requests. The funny quirk of that is if you paste in a link to a pull request into Slack, Slack expands the kind of title of the pull request and sees the 6-digit pull request number and thinks it's some kind of hex code. And so you can see it puts kind of little color swatches next to your pull request, which is quite good fun as we watch them evolve through the spectrum. And I suppose I should say that the 3 main tools we use for kind of observability and error tracking and actually monitoring our software once it's in production are Sentry, which I'm going to talk about obviously in the next few slides. We also use Datadog for its kind of APM and log ingestion kind of functionality. And we also use CloudWatch. We're already using AWS, and we publish a lot of kind of custom metrics to CloudWatch, which we can then kind of put on dashboards in offices using Grafana. Okay, so Kraken's code base is big. And it changes very rapidly. We've been doing continuous deployment since the start of the company for 8 years. We deliberately keep our processes very lean. And so we don't put a lot of kind of barriers and process in the way of people shipping new releases. Have about 500 odd developers working kind of globally around the world. We do around 160 releases of this one big monorepo every day. So this graph at the bottom of this screen shows just from the last week the number of merged pull requests in that particular repo. That's quite lumpy, of course, with the working week, but it averages around 160, spikes up to around 230, something like that in the last 2 weeks. That's quite a lot. And we have around 20 separate production environments. So kind of technically, we're doing around 2,000 to 3,000 production deployments every single day. That's like kind of one every 9 minutes or so. No, I think that's on the releases. I think it's one release every 9 minutes. So just during the course of this talk, we're going to release kind of 5 or 6 times, something like that. Okay, so it changes fast. Sentry. Okay, so if you haven't seen Sentry before, I'm going to show you, some of its functionality, the bits that we use, mainly the error tracking part of it. I'm not going to talk about some of the other things that Salma mentioned, like the performance feature and some other things like that. So this is a quick screenshot of a detail page for an issue. So that's something that's gone wrong in our application. And I will draw your attention to other bits of it as we go through some of the later slides. Broadly, it's kind of summarizing everything that happened with some uncaught exception in a Python application. So it's going to show you the exception message. It's going to show you how many times it happened, when did it first happen, how many times it's happened today, which release did we first see that in. It's going to show you a whole load of kind of tags around what environment was it in, which logger is used, what version of Python and Django and all that kind of stuff was were in effect at that time. And then it's going to, you can't really see it perhaps because it goes off the page here, but it's going to show you the whole kind of stack trace of that error, right from where it was kind of raised to where it was kind of caught. And so, and then you can see the whole stack trace, and you can see the variables in each frame of the stack as well. That's super useful for debugging. Anyway, that's enough for now. As I say, I'll draw your attention to some of the interesting bits in a minute. Okay, so that's the end of the introductions. So let's talk a little bit more about how we use Sentry, how we find it useful. And just to frame that, it's helpful for me to just draw your attention to some things around our software engineering culture at Kraken Tech. So let's start with that. So 3 things. Ever since the start, we've really valued kind of simplicity, if you like, in our choices. Always choosing like the simplest possible thing that can work. Doing that for as long as we can until it really hurts. It's too simple, and then we'll do something more complicated. I mean, hence the monorepo, if you like. That was the simplest choice. Using Python and Postgres and that kind of thing, that was the simple, boring, trusted choice we did at the start, and it's got us really far. We all, and expanding on that, I suppose, we have a minimal viable everything kind of policy within Kraken Tech. That's trying to keep our code bases simple, our kind of architecture in production, that topology simple, but also our processes, how much you have to do to kind of ship a release, how our meetings work. We're always trying to keep people's weeks super productive. They don't, as few meetings as we can get away with. Always challenging when people try and introduce more complexity. Always trying to keep things really lean and simple. And complementing that, we have a culture of kind of this high trust, where we'll give people lots of responsibility, and let them go away and trust them to do the right thing and to do great things, there'll be some kind of audit trail, just like a kind of like git commit log or some immutable log of actions in some other system. And that applies not just to our engineers writing code, but also to our staff who are dealing with customers. The key difference between Octopus as an energy company and some of our competitors is the people who answer the phone, where you can do almost everything. You've got a debt problem, you've got a payments problem, you've got a metering problem. They can solve that for you. They're trained across all these areas. You don't get this phenomena where you kind of phone up and someone tries to have like, oh no, I need to transfer you to this department. And they're like, oh no, you actually need this department. And you kind of just get bounced around all these different departments. That's not how Octopus works. Because again, we have this high level of trust in our staff. We give them lots of responsibility. We have an audit trail around what they do. Anyway, so bringing it back to kind of software engineering, this high trust manifests itself in developers being responsible for the entire life cycle of a piece of work, right through from making sure there's a spec that's been written, it's unambiguous, people have thought about success. What does it mean for this to, to be done? Or acceptance criteria, if you like. Obviously, they'll do implementation, they'll pair program, they'll write tests, they'll go through the code review process. It's up to them to kind of get code review from the appropriate people who are going to give them the confidence that their work or their pull request is going to do what it's supposed to and is implemented correctly. And then they're responsible for deploying it as well. And because we do continuous deployment, that's often just press and merge on a pull request. But crucially, they're also responsible for verifying that it does what it's supposed to when it goes to production, and it hasn't introduced any errors or regressions or any other problems. And a key part of this is we don't have a QA department. There's no team called the QA department whose job it is just to do kind of quality assurance on the work we do here. Doesn't mean we don't do quality assurance, but it's more of a hat you wear, or that different people wear, rather than a kind of person or a team that has that kind of dedicated role. So we'll give ourselves confidence in the work that we're doing through pair programming, through automated tests and TDD, through static analysis. We do an awful lot of kind of linting using Rough and Fixit and Flake8 and Bandit and various other things in our kind of CI pipeline to make sure that everything looks right and we think it works. Through code review, of course, as well. And then we have kind of health checks and feature flags and ways of kind of just sanity checking things before things go out to real customers, or maybe controlling the release of it. Okay, so that's software engineering culture. So let's talk about how Sentry fits into that. I think it's helpful to approach this in two different directions. First of all, we'll kind of explore the kind of low level, something's gone wrong, I've merged a pull request, but there's a problem. How do we diagnose, how do we know about it? How do we investigate and diagnose and triage it? How do we resolve it? And then we'll take a step back. We'll pull the camera right out and we'll look at it more holistically and ask, well, how much technical debt have we got? Have we accumulated around unresolved errors? How can we analyze that? And how can we focus our efforts on actually dealing with it, paying off some of that debt? And that's part of my role, certainly, and Kraken is to have that more holistic view of how are all our teams doing with their technical debt. Okay, let's start with the low-level one. So let's imagine you kind of join Kraken Tech, you're doing some work. We'll go through that kind of journey. So, okay, basic stuff. We have a Python application and we integrate with Sentry. Okay, this is a bit of an overwhelming screenshot on the left, but the key line is this kind of 5 lines down, Sentry SDK init. This is our kind of in our Bootstrap, in our Django settings, where we're saying, okay, let's initialize Sentry, and we're going to give it like a DSM, which is kind of like what identifies us. We're going to tell it what release we're in. We're going to tell it what environment. We're going to use some integrations with Celery and Django. Sentry then knows how to kind of patch itself into those processes. And we're going to get some other arguments around what we're doing with PII information, and some callbacks to do a bit of data scrubbing to make sure we never publish personal or sensitive information to kind of third-party vendors. So, and then at the bottom, we see 3 set taglines, and this is where we're just giving it some extra metadata, which we know is going to be super useful to us when we're trying to debug stuff. So what interface that is, that's kind of like what service, and then what country are we in, and what particular Kraken version. Once you've done this, Sentry will patch itself into your application. So if you ever have a uncaught exception, any kind of crash, Sentry will capture all that information about what happened, and send it off to the kind of Sentry platform where you can see it like in that user interface screenshot I had before. Okay, right, so we're integrated with Sentry, great. So that's going to give us our uncaught exceptions. But we also, sometimes we want to just catch an exception, log it to Sentry to say, oh, we need to look at this shouldn't have happened. But then we want to show the customer a much more graceful error message. We don't want to really show them the kind of, oops, something went wrong, 500, sorry about that. We want to kind of say, okay, this happened. Maybe it's intermittent. Maybe you should go and talk to our customer services, or maybe there's a way you can work around this. We're trying to, again, as I said at the start, we're trying to look after our customers. We're trying to make sure we give them as good an experience as we can. And to that end, we have a kind of custom logger within our kind of code base. And when you kind of instantiate it, it's just a wraparound Python standard logger, but it's configured to talk to Sentry. And you can give it this kind of area argument, which again is just more metadata. But when this actually appears in Sentry's user interface, we'll say, this area has come from the comms part of the code base. Great. And if you look at the screenshot a bit further below, this is an example of us logging explicitly to Sentry from a comms part of the database, sorry, comms part of the code base. And what's going on here is, I think it's something around previewing what emails might look like inside a kind of staff-facing website. You might want to fiddle around with what the kind of meter reading reminder email looks like. But it's possible that might crash with an unable to render content exception. And we don't, as I said, we don't want to just show something went wrong kind of message to the staff member. We are going to catch that exception, log it to Sentry, and then we're going to render them a much more graceful, kind of much more helpful error screen. Let's go make that slightly better. Okay, so those are the basics. So there's the two ways that we're going to send messages to Sentry: uncaught exceptions and explicitly sending exceptions that we've caught and we've handled in a more graceful one. Okay. So slight digression now. There's a couple of ways now that, having worked with Sentry and with this kind of error tracking over 8 years, it influences your own conventions, your own architecture. And I've got a couple of slides interspersed. Well, I'm just going to draw attention to some of our conventions around this. And most of these are open source as well. We have a open source conventions, coding conventions repo, where these are documented as well. And I'll share the link to them at the end. So first thing is, there's a question about when should we log to Sentry? And because we use Datadog as well, and you could kind of just publish a log event to Datadog. And our convention here is that you should only ever send something to Sentry if we can fix it. If it's totally out of our control, if it's like a timeout from some third-party vendor, okay, we can't fix that really. We're just going to have to work around it, whether it's through retry logic or something else. But our convention would be, don't log third-party timeouts to Sentry because we can't fix them. We have a goal of getting our unresolved Sentry errors down to 0, and so we need to make sure that list is actually stuff that we can really fix. So that's all this convention is. You don't need to kind of read all the text. The second convention is just how to log stuff, to log exceptions to Sentry. And so what we're saying here is that Sentry is very smart. It can pick up the exceptions that's been raised. So you don't need to kind of format it into the string that you pass to the logger.exception call. You can give that a more human readable error message like, oh, unable to, whatever, talk to this vendor. And that's all you need to do. Sentry will pick up the context and the exact exception that had been raised that led to it. And it leads to better grouping in the Sentry interface as well. And so anyway, so there's some guidance for new people on how you might integrate with Sentry when you're writing code. So you've written your pull request, you've got it approved, you've written some tests, brilliant. You've hit merge, it's gone through our CI pipeline. Our CI pipeline, it's got quite a lot of tests to run, and it sometimes takes more than half an hour between merging and actually rolling out to a production environment. You want to make sure that when it does roll out, you know about it. You're there, you can be there, you can go and check it straight away. You don't want to have a thing where you merge it, you go for lunch, you forget about it. Then you come back to your desk and go, oh no, my release has created loads of problems that other people have had to step in to help with. And so Sentry has a feature that helps with this. It has a concept of releases and deployments. So what we do is when we're in our CI pipeline, we register that there's a new release about to be deployed. We just identify it by the Git shard. And then when it actually deploys out to our production environments, we'll also talk to Sentry to say, by the way, that release is just deployed to this environment. And that triggers emails to the people that worked on that pull request. So all the authors of the commits, I mean, this example is just me, will get a notification. It can be in Slack. It can be by email to say your release has just gone live now. This is probably a great time for you to go and check that your work is actually working correctly. And you can go to Sentry and it will show you if there's any new issues that have appeared since that particular release. That's super helpful for kind of catching any errors early. Let's say you do that, you go and look at your release, it's all fine, no new errors since it went live, great. You go back to your other work, but maybe there is a problem, but it takes a while to kind of appear. And so let's say, yes, there is an issue, there's an unhandled exception, Sentry catches it, it sends it over to the Sentry system. So then you can use this thing around automated assignment. So Sentry can look at your code owners file from the repo in GitHub, and then work out which team kind of owns that error, if you like. If the exception got raised from a part of the code base around billing, we'd have a code owners rule that says, oh, our billing team is responsible for that. And then what we do at Kraken is we have alerts set up in Sentry to say when there are new errors assigned to the billing team, I want you to send a notification to a Slack channel to say, hey, billing team, there's something you need to look at. So all of our teams will have a kind of alerts channel, if you like, where Sentry will send notifications to say something's gone wrong, maybe you should have a look at this. And teams will typically have some kind of interrupted engineer, someone whose job it is to kind of be looking at the kind of operation of production systems, and they'll be monitoring that channel. So they'll see the Slack message come in, they can click, they can see quite a lot of metadata just from the Slack thing, but they'll probably click through, have a look at it, has it been introduced by that release? They see all the metadata and they can work out what to do, whether we need to fix it right away, whether we need to go and find someone, or what have you. They can do the appropriate response. So that's really useful. It's a great way of responding to any possible issues that have come from a release. Okay, so that was automatic alerts. Another way where you might find out about a problem is maybe a member of staff or a customer, they make some web transaction. If 500s, there's an error, there's an uncaught exception. For our staff-facing systems, we will show this is our default kind of server error screen. We would put the Sentry error ID in that message with an easy copy to clipboard button. And so if a member of staff wants to come, to us in Slack or something, say, hey, I had a problem, I was trying to do this, they can paste in the error ID and we can drop that straight into Sentry and find exactly what error they had and see exactly why that happened. And then we're in a much better place to kind of investigate it and fix it, that kind of thing. Okay, so that's a kind of more manual surfacing of an error. So those are the three things, I suppose. You can after you get the release notification, go and check yourself. We'll get automated alerts, and you might also get kind of manual kind of messages from your staff or maybe your customers, and then you can go and drill down exactly to the error they had. So, next. Oh yes, I'll put a red circle around it. There we go. Okay, right. So we know there's an issue. We're looking at the detail page. Need to do some diagnosis. We need to work out what's going on. How serious is it? Is it a real problem? Is it like something we need to drop everything for? Well, there's lots of ways you can assess this. The tagging of a Sentry issue is super useful. So as I showed you earlier on, we put a custom tag in for what an interface name is for an error. And that lets us look at this, an issue, and say, well, which of our websites or which of our kind of services is this affecting? Is it a support site, the worker pool, API site? And it'll break it down for you in terms of percentages. We can see which environment it affected, which of our clients are affected by this. Is it in their test environment or their production ones? And if you remember from our custom logger, we passed an area tag to say whether it's coming from like a financial part of the code base or a debt or an industry or billing. All these things make it super useful to kind of assess what kind of error is this? Who's it affecting? Which lets you kind of work out how serious it is. As well as that, we use TamperMonkey, which is a Chrome extension, which lets you write kind of little JavaScript files that kind of augment a particular web page. It basically lets you kind of fiddle around with someone else's web UI to scratch your own itches and add little features. So one of the things we do is we have a couple of scripts that will look for the Datadog trace, which is often in the tags, and I'll just turn it into a link to the appropriate page on Datadog, so people can just click straight through from that. And we actually do the same thing with our own account numbers, just making it easy for people who are wearing that detective hat to jump to the kind of resources they need to debug something. So TamperMonkey is really cool. Definitely recommend using that. Okay, so just on the final bit, you've diagnosed the bug. You've seen all the information in the stack trace and what, where it's affecting. Okay, fine. Let's write another pull request to fix it. The neat thing you can do is in your commit message, you can use some kind of commit syntax. This kind of fixes, and then this kind of, you can see this Kraken core 1 npj is kind of like an identifier, a short identifier for the issue. You put that in your commit message, Sentry will pick that up automatically and mark the issue as resolved. That's really neat. And I think that's the end of that particular approach. That was a low-level solve one particular error aspect. So let's zoom out and let's have a look more holistically at technical debt. How much do we have and how might we attack it, specifically around errors ultimately here. So we care a lot about technical debt at Kraken Tech. We measure it, we track it, we put it on dashboards. And so we have some like custom tools that will use Sentry's API to publish metrics about how many unresolved issues there are over time, how many unresolved issues each team has over time, and that kind of thing. And we actually have big dashboards in our offices that will put these in big red numbers, and you can see how many new issues we've had today or which teams have got the most errors. That's really useful. Let me see. So in the graph at the bottom of this slide is just showing a couple of error numbers for some of our teams. Some of them slightly too high there. And so we also have a kind of Sentry Zero kind of long-running project that obviously we want to get down to 0 Sentry errors. And we have various projects to kind of try and burn them down. Teams will do it as part of their business as usual work. But we also have something called a Kraken Spa Day. That's once a month. It's actually this week. It's quite exciting, which is a break in rhythm from your normal kind of feature and kind of normal work you'll do within your product team, where people spend the day working on kind of technical debt topics. And burning down Sentry issues is definitely one of those. Maybe looking at all the ones for your team, making sure there's nothing too serious there. How many can we fix in one day? Sometimes people have kind of gamified it and had special kind of, bug hunt days. How many Sentry issues can we clear down? That kind of thing. But broadly, we put a lot of effort into paying off our technical debt, and like kind of unresolved errors is certainly one of them. And so I'll show a little bit more on this in a minute when I do a case study of how we might tackle this. Just to kind of change track a little bit, and another holistic thing around Sentry is a key. We actually use it as a key part of our onboarding process, because pairing with someone and fixing some Sentry issues is a really great way of kind of inducting them into your organization, because you can often find some relatively shallow issues to solve. You don't need months and months of domain knowledge. And if you pair with someone and watch someone more experienced to see how do they triage an error, how do they assess how serious it is, what are they looking at? Are they looking at which environments or how many times it happened or when it was first released? That's really instructive. And then how do they debug it? Are they just looking at the stack trace? Are they kind of writing a test locally to try and recreate? You'll see how someone who works at Kraken Tech, what kind of things they're thinking about and how they go about solving an error. And they'll see that kind of through to the resolution process. If you pair with someone right through from creating the pull request, going through code review, getting it merged, writing tests, all that kind of thing. And so just anecdotally, yeah, it's a great way of onboarding people and joining a company. Okay, so a couple more conventions that have been driven through our use of Sentry. One is that this is quite Django specific, I suppose. When Sentry prints the stack trace and it prints the frame and the variables in each frame, it's just going to use the kind of repr, if you know in Python terminology, that REPR, the representation of the object. It's going to print that. And so it's really useful to ensure that uniquely identifies the object that you're talking about. So with the example of like a Django model instance, it's going to print this dunder string kind of method. And so if that's not unique, if your dunder string doesn't uniquely identify that particular row in the database, it's much harder to debug because you don't quite know which one caused the issue. So we have a convention that says always make sure that's unique. And just bluntly, just shove the primary key in it if you like. It's a bit ugly, but it works. It'll make your Sentry detail page that bit more useful. Okay, so that was one convention. It's just kind of a more abstract one. Is because I mentioned before about having We only want things essentially that we can fix. You often see this kind of pattern around handling exceptions, where we want to distinguish between anticipated exceptions, like stuff that we know that goes wrong, but we can't do anything about, and then stuff that has gone wrong. We weren't expecting it in the slightest, but so we do want to send that to Sentry. So this kind of try except pattern you see in the code snippet, where we're trying to do something, we're catching some class of exception, where we're like, oh, that's happened again, timeout with a third-party vendor. We're not going to send that to Sentry, we'll just deal with it some other way. But then a kind of more of a catch-all, but this is the other thing we weren't expecting. We do want to send that to a Sentry, and we'll do something more graceful for the customer. This is one of our conventions. We want people to follow this pattern a lot. Again, it's to try and make sure we only put stuff in Sentry that we can fix, and to make sure that we do something graceful for the end user. Okay, so that was number 4. This is the last one. Fairly obvious, I suppose, but we have a convention that says, you shouldn't be able to induce a 500, like an error, an uncaught exception, from your application. And okay, that's kind of obvious, but when you use Sentry for 8 years, you realize that if something can go wrong, it will go wrong, and you'll get an exception for it, which could have been avoided. So, okay, what's an example of this? Things like, well, in Django, assuming that ID that's in the URL always maps to an actual object in the database, and it's always going to be there. That's true most of the time, but it definitely won't always be true. And so you sometimes see code in Django which raises a does not exist exception. It ends up in Sentry. That we don't want that. We have, this convention is all about avoiding that kind of thing. Another example might be assuming there's always some query parameter present, assuming that value is always a valid integer. It's just defensive coding, really. Another classic one is assuming that JSON payload is actually valid JSON, and it's not going to raise a decode error when you try and decode it. So as a code reviewer, this is more of a convention for code reviewers. You're looking at someone's new interface code, their new view, whatever it is. You should always be thinking, how can I make this, error? How can I make an exception be raised? What kind of demonic payload can I submit here, which would cause this to crash? It's quite a useful kind of rule of thumb as a reviewer, and very much driven by our seeing all the stuff that ends up in Sentry that we thought would never happen over the years. Okay, right. Near the end now, 2 quick case studies of those 2 approaches, the kind of low-level alert resolution and then the tech debt burn down. So, alert to resolution. This is real. These are screenshots of a real issue that happened this week, I think. So this is a screenshot from the activity part of an issue. I'm just trying to show the timeline here. It says 4 days ago, Sentry encountered the issue, and we can see it got auto-assigned using a code owner rule matched on this Octo-Energy plugins territories ESP. Okay, so that's been assigned to our Spanish team. We think that's, they're accountable for this. That's going to trigger alert in their channel. Someone's going to triage it. Someone's going to go and look at it. They've jumped to the detail page for this error. It's like a no ledger number exception happened on this particular URL, and they've got all these tags so they can see which release was it, what browser was used, all kinds of things, what environment was it running in. Okay, so they can start to do some triage, see how important it is, do we need to fix it? They can look at the stack trace. Here's some screenshots of what the stack trace looks like. You can see it kind of walking all the way through our application. You can see the actual codes where the exception was raised. This is all really useful. And we can see some more metadata about what environments did this affect, what interface, what releases has this affected, and which accounts have been affected by this. Lots of different ways of trying to assess it. Great, so we've looked at all this. Well, someone literally did this 4 days ago. And then another useful thing that Sentry does, it will actually kind of point the finger a little bit and say, well, we think this might be the commit that introduced it. And this does sound like it might be related because it's a message called assume there's always a ledger number. I did get Sam's permission to put his name in the thing with this, mainly because he wrote an amazing commit message for the pull request that fixes it. So Sam's, gone in, triaged it, diagnosed it, and wrote a great pull request with a brilliant commit message for future maintainers that fixes it. And as you can see right at the bottom of this screen, he's used the Sentry syntax to automatically resolve it. And once that's been pushed up and merged, we'll see the Sentry automatically picks up the pull request and marks it as resolved. Brilliant. So there we go. That's the whole journey of an error happening. You're getting picked up, like triaged and fixed and resolved. Very nice. And there we go. We see on the detail page, it's now been marked as resolved. And so we're done. Open and shut case. So let's do the other one. Let's do the zoomed out, holistic tech debt. So this is the kind of thing we'll do on Friday on spa days when we're looking at our Sentry Zero project and thinking about, we publish way too many errors, how do we burn them down? Well, you might say, well, where should we devote our energy? How do we decide which of these many thousand errors that we should try and tackle? Well, there's many ways you could do this, but 3 candidate ways would be just sort by frequency. Go and try and fix the errors that happen the most. And in Kraken, in applications like us, where we're dealing with billions of transactions a day, some of the errors happen an awful lot of times. And a lot of them don't actually have any customer detriment. They're all in the back-end system. There'll be some kind of retry, catch-up, idempotent kind of logic that means that it's not actually a huge problem. Probably something we should fix, but not super urgent. But still, you see some really big frequencies. But maybe you could do it by customer impact. You can actually sort issues by how many customers have been affected by this. And that's probably a more impactful one. We want to be looking after our customers and our staff, making sure that their days aren't ruined by 500 error pages. Or maybe you can even do it by embarrassment factor. For instance, in Python, like an unbound local error, I would say is probably the most embarrassing exception to come from a piece of work. And you can just sometimes filter for these and find the real low-hanging fruit. This is quite a good one when we're doing onboarding and that kind of thing as well. Anyway, but one thing I did quite recently was I did it by frequency. So this was a screenshot from a while ago of our most frequent errors. Some of these have happened more than 1 million times. A lot of them are to do with event sourcing, all this kind of executing process side effects. Messages you can see in this list view. So I sorted by events to get this page, and then I went and looked at some of them. Some of them I couldn't fix, or I delegated to the team in question, but there was a whole load of them I could fix. So here's a quick snapshot from GitHub, wrote a load of pull requests, kind of tagged them with a Sentry fix label, and then these merged in mid-Jan, and this is a graph of our kind of total number of errors that we sent to Sentry, and you see the progress we had. That's several tens of millions of errors we stopped sending to Sentry during that work. And so I suppose that's an example of this kind of more holistic tech debt kind of payoff using Sentry. Anyway, so I've got to the end of my talk. How much have I gone over? I've gone over a bit, sorry about that. And so let's quickly summarize. This Kraken platform is an energy and utilities platform. It's built by Kraken Tech, which is part of Octopus Energy. It comprises a really big Python monorepo. And Sentry is a key tool that helps us, evolve it really quickly and stay on top of technical debt and make sure that, we're not, we're looking after customers and making sure that we're dealing with errors when they happen. Obligatory hiring slide. We are expanding globally, and if you just Google for Kraken careers or something, you will find us. I forgot to say that we're nothing to do with the crypto exchange Kraken or the Git client, Git Kraken. We are a separate entity to them. And just before the Q&A, here are some of the ones that came through registration. I think most of these have been covered already. We're not Git Kraken. I'm afraid I can't really talk about the customer specific code. I've definitely run out of time for that, and that's like a 4-hour answer. Any tips for Django? Just go and look at that. Did I put that in here? Oh, I didn't. I'll put it in the chat in a second. I'll put a link to our conventions. Again, if you just Google for Octopus Energy coding conventions, you'll find it on GitHub. Loads of Django tips in there. And I think I've covered most of this other one. Around how we do strive for 0 issues. I've showed how we triage. We do use Datadog. We do spend time on it. I can't say exactly how much. And I suppose that's everything from this slide.
Thank you so much, David.
Sorry,
great.
Do you know what?
I don't know whether I'm allowed to say this, but it makes me really want to be part of your team. And, you're hiring.
Well, there's the link.
Your processes are excellent, and I love a good process. Thank you so much for sharing all of that. Now, we only have one. The Q&As are coming in, actually. So we have the first one from Josh Elston Green. How do you balance automated alerting without causing alert fatigue from flooded channels? Are alert channels just for alerts, or do you send them to human interacting channels?
Yeah, good question. I mean, yeah, technical debt and teams and alert fatigue are definitely all real problems, and we definitely haven't solved them by any means. And it's really up to teams, if you like, to manage their alert channels, to do the appropriate triage. And if it's getting noisy, you've kind of got to put the energy into working out why and how do we keep the kind of ratio of signal to noise as high as possible. It's kind of like gardening, like you have to just constantly put energy into it, because it's just going to go crufty and weedy and not as valuable. And it's just something you've got to allocate the time for, I'd say. But it's a never-ending battle, definitely. It constantly needs tuning as we grow and as new kind of error patterns emerge. Sorry, what's the second part? Alerts are just for alerts or do something human interaction? Well, I mean, the alert channels are for the teams to monitor, and so you do have humans. Someone who's the kind of interrupted engineer whose job it is to stay on top of them. And so one thing we try and do is provide some kind of guidance for teams overall about kind of best practices for managing their technical debt. That's an active project at the moment, actually, to try and provide more documentation and training, so teams can kind of share best practice about staying on top of all these kind of things. And there's other buckets of technical debt other than errors as well.
One of the things that I think is really important actually is, like, you seem, David, to be like the owner of these processes, or maybe there are more than one. But I remember working for a company many years ago. We were building a mobile app and we used Sentry. And we got loads and loads and loads of noisy alerts, and we ended up ignoring them, because if you don't have someone who is owning them and putting those processes in place and making sure that people are aware of the processes and they are aware that they own their channels that the alerts are posted to, they get lost. So I think the process part, I think, is really important in that, and keeping on top of it and having people to lead that and spearhead it. So I think that's a key part. The human element is part of that.
It's interesting, definitely. We kind of try and put gentle pressure, if you like, on teams to stay on top of technical debt. You can do it in a quite shamey way by publishing like leaderboards of who's got the most. That's not always that effective. It's more like you want to do some analysis to see which teams have got the biggest problems, and then go and consult with them, go and help them and say, how do we fix this? But there's lots of different kind of, and often quite political, kind of hearts and minds kind of problems around and helping teams stay on top of technical debt. It's definitely I'm sure it's an active problem in all software engineering organizations.
Yeah, exactly. Okay, I'm going to ask you a question from Tim Thornton. How big do you see the Python monorepo getting, and what problems do you see as it grows?
Yeah. I think I mentioned in the slides about we do the simplest thing for as long as we can until it really hurts, and it is starting to hurt in some ways at the moment. So really large test suites have their own problems. I mean, we're moving away from running them all the tests, if you like, on every kind of release. We're doing a lot more kind of conditional, using heuristics to kind of run smaller subsets of tests to keep the speed up. So one of the problems is that your deploy pipeline can get quite slow. Flaky tests can be a real problem when you've got 100,000 or so tests running, because especially when you're very global, time zones are a nightmare, and you always find people make bad assumptions about dates and things, which lead to flaky tests that fail, between 1 and 2 in the afternoon in New Zealand or something like that. And you get this phenomenon where the British team gets frustrated with the Australian team and vice versa, because it's really easy to write tests that pass perfectly, for you in your time zone, but not in someone else's. There's 1,000 other ways that flaky tests can't emerge. We've even got a blog post. I've learned a lot about flaky tests over my time working here, all the ways that can happen. Another thing would be kind of boundaries as you go. It's fine when you're 30 people. It's fine for everyone to kind of work everywhere in the code base. But when you're 500, you kind of want to have more defined domain areas. So the billing team looks after this part of the code base, and they don't really want other teams just kind of coupling their code to the implementation details of it. They want a bit of privacy, if you like. And you have to put quite a bit of effort to make that work in a monorepo. It's all solvable. But our approach now is evolving a bit to use separate services for new functionality, and especially as we kind of become more energy agnostic, and it's not just about gas and electricity, it's about water, it's about broadband, it's about telecoms. We're starting to kind of make Kraken more kind of agnostic in its core and have a much more of a plug-in architecture for how do you integrate with these different industries. And you can do that at various levels of abstraction. You can do it within one code base. We're increasingly starting to use external swappable services, if you like, as well. So I'd say if you're going to plot a graph of our size of our repo, it's definitely starting to plateau now. And who knows, it might even start to decrease in the next year or so. So yeah, we're definitely reaching an inflection point where we need to start changing, arresting the growth a little bit, because the pain is starting to hurt.
The best pull request contains more lines of deleted code than added code. That's what I always say. Next question. What is your favorite less known Django plugin?
Oh, that's a good question. What do we use that's really interesting? I mean, we do a lot of stuff on typing, like MyPy and Django stubs. I can't really say they're my favorite, but the ones I end up interacting with a lot. What's a good one we use in Kraken? Django plugin.
I mean, you might not have one. That's a valid answer.
It's the kind of thing I haven't thought about for ages. It's probably something like PyTest Django. I really love PyTest, and the PyTest Django plugin, which just kind of links the two together, provides some nice fixtures. That's really cool, actually. I'll have a think about that one when I'm doing the other ones. I'll see if I can think about some others.
Thank you. And on the note of testing, Gaston asks, regarding tests and monorepo, have you considered opting pants build to run tests for only change parts of your Python monorepo? That has been pretty useful to us.
Pants build is not a name I'd come across before. I'm going to write that down. No, I'll check that out. We've got some of our own strategies for the conditional running of tests. We can use the coverage database is an interesting way of mapping from like a change set to the test that we might need to run to test it. We also have some other strategies around kind of just file conventions. Like if you change this file over here, then we've probably got a unit test that mirrors its structure. We can use that as well. You have to be a bit careful of like things that change global things like settings or model fields, and we have a slightly different strategy for that. This is all a bit work in progress, to be fair. We haven't really done a lot of it in our real main pipeline yet. But no, I haven't checked out PantsBuild, and I will do that. So thanks for sharing it.
Thank you for that, Gaston. Okay, so I think you've already answered this. But Sarah asks, is there anything you use in combination with Sentry to resolve issues in Kraken?
I mean, of course, there's Datadog as well, which could be useful if you want to look at some logging that correlates to it. I mean, of course, you might local testing. I mean, you might just do some manual testing. You might go use the Sentry page to go and actually find that page, see if you can recreate it. I can't think of a particular tool other than Datadog. Other than that, it's just kind of more standard detective techniques, if you like, and trying to recreate it, trying to kind of validate your own hypotheses, that kind of thing.
Thank you. And I think this is going to be the final question, because I've got a few things to tell you about after this. So one question, this comes from Juan. One question regarding big, busy Monolith. How does Kraken manage the merge queues with so many releases to prod every day? I was thinking the same.
Yeah, we don't have like a fast forward policy, if you like, for pull requests. So you can merge a pull request when it is a little bit behind master, because it wouldn't be tenable to kind of require everything to be fully rebased. We don't use a merge queue at the moment. I can't remember exactly why off the top of my head. I'm sure there was a reason. It doesn't quite make sense to us. But to avoid, so implicit conflict is the name we give to the problem where your main line branch breaks because of a merge pull request that is slightly in conflict with some upstream changes. And we have some tooling around that where we can register like high watermark commits that says you're not allowed to merge unless your pull request contains this commit, because we know this is like a really widespread one. It's really likely to lead to implicit conflict. And we also have like a custom GitHub action which will kind of put a failing check on your pull request if it's older than, I think, 2 days. Basically, you have to stay fairly up to date with mainline. Can't get too far behind, just to avoid these problems of, yes, it's a real thing as we identify about how you merge so many pull requests in. Yeah, good question.
Busy team. All right. Thank you so much. Please, can you go to the next slide, David? Thank you, everyone, for all of your questions. Thank you, everyone, for sticking around. A really interesting presentation. I learned some stuff too. And if you are interested in some more similar workshops, we have a workshop coming up on March the 5th about mobile app performance monitoring best practices. Mobile, we know, is a very different beast to other types of web-based applications, and it comes with a whole suite of tools in Sentry to help you monitor and fix those things as well. And we've got Sentry launch week number 2 Coming up at the end of March, March 18th, 22, we are going to be releasing and talking about lots of new features and products coming out on the Sentry platform and how it can help you make even better software. Next slide, please, David, the final slide. I want to thank you all for joining us. Thank you again to David. I am a customer of Octopus Energy. I love Octopus Energy and what they do. And clearly, your engineering practices are making it so that the product is even better. And I can definitely attest to the excellent customer service. Thank you again, David. And reminder to all participants, please fill out the survey. It won't take you very long and it will help us make better, even better workshops in the future. Once again, thank you, David. Everybody have a great day and we'll see you at the next one. Bye-bye.
Bye, everyone.